All right, so let's solve cosine of x minus the square root of 3 equals negative cosine of x. So we want to solve for cosine, obviously, right? Since it's the only trig function we have. So we need to get our cosines together. So what do you want to do? Yeah, why don't we move this cosine of x over? So we're subtract it. So when we do that, we get negative square root of 3 equals, what's negative cosine minus cosine? Negative 1 minus 1 is, so we have negative 2 cosine of x. And how do you get cosine by itself? Divide by the negative 2. And so I'm going to put my cosine first. So cosine of x equals, what's a negative divided by negative? Positive. So we got a positive square root of 3 over 2. Now, cosine is what? X or y? Oh, we got to think way back, don't we? Because we're thinking about our unit circle because it said exact values, right? So cosine is x. So think about, get your unit circles and look. Where is your x value a positive square root of 3 over 2? In quadrant 1 and in quadrant 4. So what are my angles? Give it to me in radians. What is my angle in quadrant 1 that the x value is the square root of 3 over 2? Pi over 6? No, pi over 6, right? And what about quadrant 4? 11 pi over 6. Now, the only thing is when we're looking at our unit circle, you told me that like pi over 6 is one of them. So right here, correct? So if I go here, I'm there. But what if I go another full circle? Is it going to be the same? If I use a coterminal angle, is cosine of x still equal to the square root of 3 over 2 at 13 pi over 6 right here? Yes. And what if I go another full circle? Is it equal to, is cosine still square root of 3 over 2 there? And if I go another one, and another one, and another one, it's equal, right? So where does it stop? It doesn't, you're right. So what we're going to do is, because in the problem there, it didn't tell me only from 0 to 2 pi. After each of these answers, you're going to put plus 2 pi in. And so what that does is it covers all of the coterminal angles for both of them that are going to land in that position.